In this video, we will be going over the different methods to obtain data, whether it be from a survey or an experiment. The first method, which is also the most accurate, is a census, which is an official count or survey of a population, typically recording various details of individuals. For instance, if a governor wants to know the opinions of his constituents on a certain issue, he would get the most representative data by surveying everyone in the city. While this method is accurate, it is obviously unrealistic because it will take far too long to be viable. Instead, our governor could take a sample survey to estimate the true opinion of the city's population. A sample survey is a subset of individuals in the population from which we actually collect data. For example, the governor could randomly choose 1,000 people per district and only interview them about the topic instead of the entire population. For this proportion of the population, the governor is able to estimate the true beliefs of the population without having to survey every single person. What if the governor wanted to prove that the increased deterioration in his roads has been caused by the growing Prius population? He would need to collect data through an experiment. An experiment deliberately imposes some treatment on individuals to measure their responses. In this case, our governor would randomly sample a group of Priuses to represent their total population. He would have to randomly assign 2 roads of identical age and wear to either of the Prius group or the control non-Prius group. A control is a baseline group that receives no treatment or neutral treatment. The governor would use this group as a comparison to the Prius group to see if the Prius population actually caused the road deterioration. If the governor doesn't have the funds for an experiment like that, he could instead perform an observational study. An observational study draws inferences from a sample to a population where the independent variable is not under the control of the researcher. If the governor has the city records and the street camera video of deteriorating roads and studies those, he can get an idea of whether or not it's due to the rising number of Priuses. But what can the governor actually make conclusions about from his Prius experiment? The scope of inference for a study or an experiment is the extent over which inferences are to apply, where extent is suitably defined as the population of interest. Because the governor is only looking at the roads in one city, he would not be able to generalize the results for cities across the country. Even if his subjects are randomly assigned, he can only make conclusions about the population that he drew from. Now, here are some common mistakes made by students when approaching problems relating to these topics. Many students forget the difference between studies versus experiments. The main difference between these two is that experiments impose treatment upon subjects, whereas studies only observe subjects without imposing any form of treatment. The other common mistake that students make is incorrectly drawing conclusions based on the given study or experiment. We must remember that studies demonstrate correlation only, where experiments establish causation. Subjects that were randomly selected allows conclusions to be made about the general population, but subjects that are not randomly selected only allows conclusions to be drawn about the subject group, not the overall population. If you want any practice problems, go to 2003 number 4.